Maths Aspirants Groups organizes several online problem solving sessions to help the students who prepare for national level competitive examinations. And as a part of this series, today we blessed to have Ms. Kajal Sachdeva, a research scholar from Maharshi Dayananda University, Rohtak, Haryana. Ms. Kajal is now pursuing, now a PhD student in MDU, and she completed her MSc from the same university, and she qualified GATE examination with all India rank 197 and CSER NET 3 times and CSER JRF with all India rank 53 in 2020, and also in our platform Maths Aspirants, she had done one class, I think in the last week, on some part of differential equations. Now today's lecture is a continuation of that lecture, and in this lecture she will address the Cauchy-Euler equation and method of variation of parameters. All these are in the syllabus of GATE examination as well as JAM examination, and of course in the NET examination. So I hope that today's session will be really useful in your final round preparations for these exams. So wishing you all the very best in the examinations, and I welcome everyone to this program, and I express my sincere gratitude to Kajal for being with us. Welcome, Kajal.
Thank you so much, sir. Good evening, everyone. So, in today's lecture, we are going to learn about what is Cauchy-Euler equation and method of variation of parameters. In continuation of last lecture, we have learned about what is a linear differential equation with constant coefficient and how we found the solution of that equations by finding CF and particular integral. So there are so many cases for that, and today we are going to do Cauchy-Euler equation, which is also generalization of equation with constant coefficient. So Cauchy-Euler equation is a linear differential equation of that form. Here the form is an x raised to power n dn y upon dx n plus an minus 1 x power n minus 1 dn minus 1 y upon dx n minus 1 up to a naught y is equal to gx. Here you can see an minus 1x, a1, a naught, all are constants, and the speciality of this equation is the power of x and the differential order matches. Here xn and dny upon dxn. And similarly in the second part xn minus 1 power and the differential has order n minus 1, and going to the last here x dy upon dx plus a naught y. So here x power 0 and the differential also is of 0th order. So these kind of equation where the power of x matches the order of derivative, this kind of equation is known as Cauchy-Euler equation, or we can say equidimensional equation. Cauchy-Euler equation and equidimensional equations. So for this we have a method to find solution. We have even a short trick to find solution. Just put x is equal to e raised to power t. We will do a substitution. X is equal to e raised to power t. By this substitution, our Cauchy-Euler equation will be converted to the equation with constant coefficient, and whose solution we know earlier. So let's take an example. So we are taking an example. Solve the differential equation x square d2y upon dx square minus 2x dy upon dx is equal to x square plus 1 by x. Here we can see we have equation where x power 2 and d2y upon dx square. Here x power 1 and the differential order is also 1. And this is a non-homogeneous part. So this type of equation is Cauchy-Euler equation. And for finding solution of this kind of equation, we will substitute let x is equal to e raised to power t. By this substitution, what happened? We can write xn dny upon dxn as d, d minus 1, d minus 2 up to d minus n plus 1 y. So this part converted in this symbolic form. Here the difference with the last lecture is on constant coefficient, and by this substitution and using this, we will convert the equation number 1 into a equation with constant coefficient. So let's start. Here x square d2y upon dx square can be written as d minus 1. As for part 2, we will stop up to d minus 1. Here we can see x square d2y upon dx square can be written as d minus 1. And this part will become only d. When n is equal to 1, we will stop to the d only. So here we will get d. So the second part we will write minus 2d whole by is equal to, the next one is the non-homogeneous part, which is as x square plus 1 upon x. You can see from here x square plus 1 upon x. So putting x is equal to e raised to power t, we get e raised to power 2t here, and here 1 upon e raised to power t. So this becomes e raised to power 2t plus 1 upon e raised to power t. So these are converted equation in symbolic form, and this equation have independent variable as t now, x converted into t, and y is the dependent variable for which we are to find solution. So you can see from here, this is the equation of constant coefficient type, and just we will find CF and PI, complementary function and particular integral, and we will get the solution of this equation. So this is the homogeneous part. For writing auxiliary equation first, we will replace just d by m. m minus 1 minus 2m is equal to 0. So here we get m square minus m minus 2m is equal to 0, which can be written as m square minus 3m is equal to 0. Just taking m common out, m minus 3 is equal to 0. From here m is equal to 0 and m is equal to 3. So this is the case of distinct and real roots 0 and 3. And in this case, we write CF as C1 e raised to power 0 t. Now we have the independent variable t here, plus C2 e raised to power 3 t, because as we have independent variable as t. Now C1 plus C2 e raised to power 3t, convert back into x. We have x is equal to et. This is our substitution. So when we put this relation here, C1 plus C2, et whole cube, e raised to power t is converted by x, so it becomes x cube. So this is our CF in term of x. Similarly, we find pi, particular integral. So for finding particular integral, we write 1 upon f of d into that homogeneous part. So here we have homogeneous part as in the converted equation of t, e2t plus 1 upon e raised to power t, and this is our f of d, which is d square minus d minus 2d, or we can write it as d square minus 3d. So we have 1 upon f of d, d square minus 3d into f of x, the homogeneous part. So non-homogeneous part is e raised to power t plus 1 upon e raised to power t. Going back, e raised to power 2t plus 1 upon e raised to power t. And in this, we have the method, just replace d by 2 ones and in another d by minus 1. Separate it out, e raised to power 2t upon d square minus 3d plus e raised to power minus t d square minus 3d. Substituting here d is equal to 2 as we have done in our last lecture. 2 raised square 4 minus 6 plus here substituting b is equal to minus 1 as a is equal to minus 1 here. So e raised to power minus t. When we put d is equal to minus 1, it becomes 1 minus 3 minus 1. So our final pi is e raised to power 2t upon minus 2 plus e raised to power minus t upon 1 plus 3, that is 4. So this is our pi. Also convert back it into form of x by using the relation x is equal to et. So this becomes et whole square upon minus 2 plus this is also et power minus 1 upon 4. So x square upon minus 2 plus x inverse by 4 which is equal to minus x square by 2 plus 1 upon 4x. So this is our pi, and for writing complete solution we have yx is equal to cf plus pi. So we have cf as c1 plus c2 x cube and the pi is minus x square upon 2 plus 1 upon 4x. This is our complete solution, and you can see from here what we have done. Just converted the Cauchy-Euler equation into constant coefficient equation, and the results all are same which we have done in last lecture. So this is a very simpler type of equation and easy. So moving towards our next. So from here you can see when we have real and distinct roots m1 is not equal to m2, the general solution in this kind of equation we get c1 x raised to power m1 plus c2 x raised to power m2. You can see from here what we have done. In this case, the question which we have solved, we have the solution of this form. We have real and distinct root 0 and 3, and the final solution we get in this case as c1 plus c2 x raised to power 3, here x raised to power 0. So when we have real and distinct root, so just write root x raised to power 0 and the second root x raised to power 3. So this is our general solution case. You need not remember this case. Just apply the method, reduce it into constant coefficient, and you will get the desired solution. So moving back, we have another equation. Let's try another example which is similar to this example. We can have some another equation of type this: P naught a plus bx power n dny upon dxn plus p1 a plus bx n minus 1 dn minus 1 y upon dxn minus 1 plus up to pn minus 1 a plus bx dy upon dx plus pn y is equal to f of x. This is another type of equation which is even generalization of Cauchy-Euler equation. In Cauchy-Euler equation, we have here only x raised to power n. Here x raised to power n minus 1. Here only x. This is a generalization of Cauchy-Euler equation. And we can convert this equation is also into constant coefficient equation. We will just do substitution. Substitute a plus bx is equal to e raised to power t. In previous one type, we have substitute x is equal to e raised to power t. In this kind of equation, we substitute a plus bx as e raised to power t. And by this transformation, our derivative convert into dny upon dxn, that will be converted and converted by this relation a plus dxn dny upon dxn will converted into a raised to power n d minus 1 up to d minus n plus 1 into y. This substitution will also convert the differential into this, where d stand for dy dt. Now our independent variable is t here. So let's take an example of this type also. So example number second, 3x plus 2 square d2y by dx square plus 3x plus 2 dy upon dx minus 36y is equal to 3x square plus 4x plus 1. In this example, you can see we have ax plus b power 2. Also here ax plus b power 1. So this is a generalization of Cauchy-Euler equation. And here we substitute this whole 3x plus 2 is equal to e raised to power t. Like previous one. And by this substitution, we find that a raised to power n, a raised to power n, no, b raised to power n, which is with x, b raised to power n. So just we get here, this is the b, a plus bx, this is the b. So this equation becomes, after this substitution, 3 square d minus 1 plus, from here this 3 and b power 1, 3 raised to power 1, and this will become d minus 36 and take common out y is equal to, this will become, from here we are to find the value of x first. So we can write 3x is equal to e raised to power t minus 2 and x is equal to e raised to power t minus 2 upon 3. So our x become e raised to power t minus 2 upon 3 square plus 4 e raised to power t minus 2 upon 3 plus 1. So this is our converted equation. Just simplify it. Here we get 9 d square minus 9 d plus 3 3s are 9 d minus 36 into y is equal to, also simplify this side, we get 3 a minus b whole square, a square plus b square minus 2ab upon 3 square is 9 plus 4 upon 3 et minus 2 plus 1. Now you can see from here, this will cancel out and we get 9d square minus 36y is equal to, this will also e raised to power 2t upon 3 plus 4 upon 3 minus 4 et upon 3 plus, from here 4 upon 3 e raised to power t minus 8 upon 3 plus 1. So you can see from here, this will also cancel out and we get the final equation, which is linear differential equation with constant coefficient and which have non-homogeneous part also. This will become minus 4 by 3 plus 1 that is minus 1 by 3. So this is our constant coefficient equation. In the similar way, we can solve this equation. Here D stands for curl upon curl T, d upon dt even, because this is ordinary differential equation in independent variable T. So in the similar way, we can find CF and PI here. When we find CF in this case, first we are to find auxiliary equation. So auxiliary equation is 9d square minus 36. Put m in this, 9m square minus 36 is equal to 0. And from here we can see m square minus 4 is equal to 0, which gives m square minus 2 square, a square minus b square, a minus b, a plus b, m minus 2, m plus 2 is equal to 0, which gives m is equal to 2 and minus 2. Again, this is a case of real and distinct roots. And in this case, we have the CF of type e raised to power m1x and m2x. C1 e raised to power 2t plus C2 e raised to power minus 2t. So here e raised to power 2t, again we have the substitution. But here substitution is different. Here we didn't put e raised to power t as x. Here we have the substitution. Ex plus 2 is equal to e raised to power t. So by this substitution, our equation will convert as e raised to power t is equal to 3x plus 2. Put here 3x plus 2 whole square plus C2 3 raised to power minus 2. Here power is minus 2. So we get the CF as C1 3x plus 2 whole square, C2 upon 3x plus 2 whole square. This is our CF. Now particular integral. For particular integral we have f of d as 9d square minus 36, and the right hand side we have e raised to power 2t by 3 minus 1 upon 3, which we have found earlier. So how we can solve this? Here e raised to power 2t upon 3 9d square minus 36, just taking common 1 upon 3 9d square minus 36. In this case we can write e raised to power 0t, and when we put d is equal to 2 here, this will become case of failure. You can see from here 9 4s are 36 minus 36 0. So in this case, we have the method multiplying it by t and the derivative of below part. 9 2s are 18d. This will become the derivative 18d, and from here we put d is equal to 0. So we get, when we put d is equal to 0, minus 36. So finally, we have 1 upon 54 t 1 upon d e raised to power 2t. So 1 upon d stands for integration. So integrate e raised to power 2t, which is equal to e raised to power 2t upon 2. This will become plus 1 upon 108. So here we get pi. The pi is as 1 upon 108. 54 into 2, 108. Taking common out, plus 1. T e raised to power 2t plus 1. Now we have the substitution. 3x plus 2 is equal to e raised to power 2. So by this, t will be equal to log of 3x plus 2, ln 3x plus 2. So substituting back, t is equal to log of 3x plus 2. E raised to power 2t will be written as 3x plus 2 ka whole square plus 1. So this is our pi, and earlier we have CF. For finding complete solution, we just write CF plus pi. So this is the case of more general type of equation. So these two are the generalized case of our constant coefficient equation, and many times there are so many questions from this part in even IIT JAM syllabus and GATE syllabus. So this is very scoring portion. Now coming back, so what is Wronskian? Here I am only giving you the idea, just giving you definition. This topic is itself a very wide topic, Wronskian and linear independence. We can have any other lecture on this topic. So what is Wronskian? If we are to find Wronskian of n functions f1, f2, fn, we just find a determinant n cross n determinant matrix. Determinant in which first row is f1, f2, fn, the original functions. The second row is its derivative, f1 dash, f2 dash, fn dash. And the last row is n minus 1th derivative. We just have to find the determinant of these and we will get the Wronskian of function f1, f2, fn at the point x. So Wronskian is itself a function of x, which find on the common domain, the given domain on which the function is defined. So as this will use in our next method, so just you have the idea of the definition, what is Wronskian now. So the next is method of variation of parameters. So in this method, we are to find a very special kind of differential equation, a second order differential equation, y double dash plus p function of some t, y dash plus qt into y is equal to gt. This is a equation. Notice we have taken the coefficient of y double dash as 1. This is our standard form. We can write any equation, second order equation in this form. So if you have an equation of second order, we can find the solution by method of variation of parameter. We just require the CF. We want the fundamental solution of homogeneous equation first. So if you know the only homogeneous part solution, the CF only. If you know the CF, then by this method you can find the complete solution, whatever the PI is. So we just apply a working rule. What is the working rule behind that? The solution is of the form u1t into y1 is plus u2 into y2. u1 y1 plus u2 y2. Here y1 and y2 are the Li solution of homogeneous equation. The homogeneous part equation, the CF we have. So that is our y1 and y2, the two solution, the independent solution we will take from homogeneous part, that will be named as y1 and y2. Next, we find the Wronskian of y1 and y2. For finding complete solution, we just need u1 and u2. So u1 and u2 is given by, u1 is given by minus integration of y2 into non-homogeneous part gt divided by Wronskian into dt plus c1, that is your u1, and u2 is given by integration y1 into non-homogeneous part gt divided by Wronskian y1 and y2, Wronskian of y1 and y2 into dt plus c2. So this is your working rule. By applying method of variation of parameter, you can find the solution of these kind of equation whose CF is already known. So let's take an example. So we have an example. Before taking an example, for finding CF, we have more methods. Many times we don't have equation of like constant coefficient type or Cauchy-Euler equation, but we can find CF by using these method. Just write the second order equation standard form d2y upon dx square plus p dy by dx plus qy is equal to 0. In this equation, you can check what is the value of p, value of q. If your equation satisfied 1 plus p plus q is equal to 0, then we can say y is equal to ex is part of CF. You can check this is the solution. Ex is solution if 1 plus p plus q is equal to 0. You can write one of the solution is e raised to power x. This is the part of CF. And similarly, if you check and verify this relation p plus qx is equal to 0, then you can say y is equal to x is part of CF. This will be in the CF. And 1 minus p plus q is equal to 0, then you can say y is equal to e raised to power minus x is part of CF. So more generally we have ex, x, e raised to power minus x. These are the part of CF. So this is the direct short tricks to check this will be in the CF or not. So these are going to be very useful in finding the CF. If you have any type of equation and this relation is satisfied, then you can directly say these are going to be part of C. Let's take an example. We have a equation 1 minus x d2y upon dx square plus x dy upon dx minus y is equal to 1 minus x square. So first of all, we have the standard form of equation as d2y upon dx square plus p dy by dx plus qy is equal to some function, say r, non-homogeneous one. So we can see from here, first we have to write this equation into standard form. How we can write? We have to make the coefficient 1. So divide this whole equation by 1 minus x. So we can write this equation as d2y upon dx square plus x upon 1 minus x dy by dx minus 1 upon 1 minus xy is equal to 1 minus x. So now this equation becomes our this type of equation. We can compare, this is the value of p and this is the value of q and this is our r. We have here p is equal to x upon 1 minus x, q is equal to minus 1 upon 1 minus x and r is equal to 1 minus x. So as I have said, if we have p plus qx is equal to 0, then y is equal to x is part of CF. You can see from here, we have p plus q into x. If you will do q into x minus x, 1 minus x, this will cancel out, become 0. So here we have y is equal to x as a part of CF. So I can take an independent solution of CF as x. I can take y1 as x. Again, we can check from here 1 plus p plus q. Is it 0 or not? So let's check 1 plus p plus q. 1 plus p is x upon 1 minus x and q is minus 1 upon 1 minus x. So here we get 1 minus x, x minus 1 upon 1 minus x, that will cancel out and we will get 0. Again, as 1 plus p plus q is equal to 0, so we get y is equal to e raised to power x is part of CF. So we can take second independent solution as y2 as ex. So we have, as we have second order differential equation and we have two part of CF here which are independent. So our general solution are the linear combination of this. So basically we are only to find two Li solutions which are part of CF. So these are the x and y2 is equal to Ex are two Li solution of homogeneous part. Now the second step in solving this type of equation, you can see from here we have r is equal to 1 minus x. We can solve this equation by previous method. Is there any method to solve this type of equation like constant coefficient or Cauchy-Euler equation? We can easily see from here these are not that kind of equation. We have no option to solve this equation by previous method which we have done in our earlier lectures. So now we have method of variation of parameter as we know the CF here. As we know the CF, so now we will move towards method of variation of parameter. Our next step is find Wronskian of y1 and y2, which will be given as first write y1 y2 and secondly its derivative. As there are two functions, so it will become 2 cross 2 matrix determinant x e raised to power x and its derivative 1 and e raised to power x derivative is e raised to power x. So we get here x e raised to power x minus ex. This is the determinant value. So this is our Wronskian. And we know that our solution y is equal to u1 y1 plus u2 y2. y1 y2 we know here x and e raised to power x. Now the next step is to find u1 and u2. So we have the formula to find u1 and u2 here. For finding u1, minus integration of y2 into r upon Wronskian into dx plus c1 minus y2 is e raised to power x, r we can see we have r is equal to 1 minus x. So substitute r is equal to 1 minus x and Wronskian of y1 and y2 we have x e raised to power minus e raised to power x dx plus c1. So just solving this e raised to power x 1 minus x, taking e raised to power common from denominator x minus 1 dx plus c1. This will cancel out. This also cancel out with the negative sign. So we get integration of 1 which is x plus c1. So this is our value of u1. Now finding u2. u2 is equal to integration y1 into r upon w Wronskian into dx plus c2. So we have y1 as x, r as 1 minus x and Wronskian value as x e raised to power x minus e raised to power x dx plus c2. So we can solve it easily. X 1 minus x, taking e raised to power x common, x minus 1 dx plus c2. So here this will cancel out with negative sign. Taking negative common x, this will become e raised to power minus x dx plus c2. Now for finding integration of the product of two functions, we have UV rule integrating by parts. We can write this can as first function, this can as second function. First as it is, the integration of second minus integration, the differentiation of first and integration of second into dx plus c2. We get here x e raised to power minus x minus minus plus e raised to power minus x integration again minus plus c2. So here we get x e raised to power minus x, and one more minus sign is a lower side, so it becomes plus e raised to power minus x plus c2. So this is our u2. We can take e raised to power minus x common plus c2. So we get u1 u2 also. Now the final solution is u1 y1 plus u2 y2. We get x plus c1 as u1, x is y1 plus u2 as x plus 1 e raised to power minus x plus c2 into y2 as e raised to power x. So this is our complete solution, x square plus c1x plus x plus 1 plus c2 e raised to power x. From here you can see this contains constants c1x plus c2 e raised to power x, which is the linear combination of CF part. So this is the CF here plus the remaining one has no constant. So this is our particular integral which can be compared. So this is our final solution, and the method of variation of parameter is as simpler as the other methods. You just need to know here what is the CF first. If you know the CF, then you can find the solution by using method of variation of parameter. So let's have some previous year question. Any doubt? Anyone? So our first question is from IIT JAM 2019. Here we have let yx is equal to x into vx be the solution of differential equation this. If v0 is equal to 0 and v1 is equal to 1, then v minus 2 is equal to what? Here we have the equation of type x square d2y upon dx square minus 3x dy by dx plus 3 into y. The power of x matches with the differential order. So this is our Cauchy-Euler equation. X square d2y upon dx square minus 3x dy upon dx plus 3y is equal to 0. Here we have the method. Just we substitute x is equal to e raised to power t. When we substitute x is equal to e raised to power t here, this also converted into d minus 1 minus 3d plus 3. Y is equal to 0. So we get d square minus d minus 3d plus 3. Y is equal to 0. So our symbolic form become d square minus 4d plus 3 into y is equal to 0. Writing auxiliary equation, just substitute d is equal to m square minus 4m plus 3 is equal to 0. We can see this is the minus 3 and minus 1, sum of minus 3 and minus 1, and their product is 3. So we can break down into minus 3m minus m plus 3 is equal to 0. Also taking m common out, m minus 3 minus 1, m minus 3 is equal to 0. So we get m minus 3, m minus 1 is equal to 0, which gives m is equal to 1 and 3. So here we get this even complete solution because we have only homogeneous equation. C1, the real and distinct root, e raised to power t plus C2 e raised to power 3t. And after substituting e raised to power t is equal to x, C1x plus C2 x cube. So you can see from here in the question, we have given y is equal to x into vx be its solution. So comparing our solution with this, as we have given condition on V, we have both condition on V, and we are to find the value of V of minus 2 here. So comparing it with Yx is equal to x into Vx. From here we can also take x common, C1 plus C2 x square. When we compare this with this, we get Vx is equal to C1 plus C2 x square. So here we get the value of Vx, and V0 is equal to 0, V1 is equal to 1. Substituting this, when we put V0 is equal to 0, we get 0 is equal to C1 plus C2 into 0, which gives C1 is equal to 0. It means Vx become C2x square as C1 is equal to 0. Now substituting V1 is equal to 1, we get 1 is equal to C1 into 1, which gives C1 is equal to 1. So we get Vx is equal to x square. In the question, we have asked V of minus 2. So just substituting minus 2, we get 4. So the required answer is 4. Moving to our next question. The next question is from IIT JAM 2017, also numerical answer type question. We have the questions from previous year, only single answer type question or numerical answer type question on this topic. There is no multiple answer type questions on this topic, even in GATE examination, in IIT examination, and also in NET examination. We have multiple choice answers questions, but they have only one option of these type. Other options are based on Wronskian or continuity, like this. So in this topic, we have single answer type question or the numerical answer type questions. So let's have another question. Let Yx be the solution of differential equation this. Again, you can see from here, this is the equation having x power same as differential order, x square d2, x d and y. So again, we can proceeding in similar manner. The only difference is in this question, we have condition on y. So we are to find complete solution first, y. Then after finding y, we are to put y of e and multiplying it by e square. We will get the required answer. So easy one question again. Just do a substitution. Let x is equal to e raised to power t. So this become d minus 1 plus 5d plus 4 into y is equal to 0. We can write it as d square minus d plus 5d, which is 4d plus 4 into y is equal to 0. So this is the our symbolic form and also a homogeneous type of equation. So simply we have auxiliary equation as put d is equal to m. We get m plus 2 whole square is equal to 0, which will give m is equal to minus 2 minus 2. So here we have the same roots, equal roots, real roots. So in this case, we have CF as C1 plus C2 x naught. We have independent variable t. So C1 plus C2 into t e raised to power minus 2t. Now substituting x is equal to et again. We have here t is equal to log x. So C1 plus C2 into log x e raised to power t will be x whole minus 2 power. So here we get the complete solution as this is the homogeneous equation. C1 plus C2 log x upon x square. This is our solution. But in this solution we have the Initial conditions also given, y1 is equal to 1 and y dash 1 is equal to 0. We have y1 is equal to 1 and y dash 1 is equal to 0. And we are to find the value of e square y of e is what? Simply, we have to do derivative also. So first apply this condition, y of 1 is equal to 1. 1 is equal to c1 plus c2 log 1 upon 1, which will gives 1 is equal to c1 as log 1 is equal to 0. Log 1 is 0, 0 into c2 is 0. So we get c1 is equal to 1. So our solution become yx is equal to 1 plus c2 log x upon x square. So this is our solution when we put condition y1 is equal to 1. And now take derivative as we are going to put y dash 1 is equal to 0. So taking derivative y dash x we have to find here. For taking derivative of this kind of equation, we apply u by v rule. U by v rule, derivative with respect to x of u by v function, which is equal to v square, v as it is, the derivative of u minus u as it is, the derivative of v. So, the lower part square is x raised to power 4 and taking x square as it is, the derivative of 1 plus c2 log x is c2 upon x minus 1 plus c2 log x as it is, and the derivative of x square is 2x. So we get y square x is equal to x c2 minus 2x minus 2x c2 log x divided by x raised to power 4, or taking x common we get c2 minus 2 minus 2 c2 log x upon x cube. Applying the condition second one, this is the derivative, we have the condition y dash 1 is equal to 0. So putting x is equal to 1, we get y dash 1 is equal to 0, putting x is equal to 1. Log 1 is equal to 0, 1. So here we get C2 is equal to 2. Substituting back in this, C2 is equal to 2. We get Yx is equal to 1 plus 2 log x, 1 plus 2 log x upon x square. This is our Yx. And in the final, the question wants the value of e square into y of e, which is equal to e square into y of e, 1 plus 2 log e upon e square. This will cancel out. Log e is equal to 1, so 1 plus 2 is 3. This is our required answer. So moving towards next question. Till now, any doubt? So next question is from IIT JAM 2016. Let yx be the solution of differential equation of type the derivative of x into dy by dx with respect to x is equal to x. Here y1 is equal to 0 and the dy by dx at x is equal to 1 is equal to 0. This means y dash 1 is equal to 0. Then you are to find y2 is what? So the main problem with this question is we are not getting which type of equation is this. Is this a constant coefficient equation, or this is a Cauchy-Euler equation, or any other one? So let's just write equation and solve as much as you can. Is equal to x. Here we have two function of x, which is x and dy by dx. And we are to apply derivative here. So derivative of u into v, u as it is, and derivative of v, that is d2y upon dx square, plus the derivative of first function is 1 and second function as it is dy upon dx is equal to x. Now here we have the equation x into d2y by dx plus 1 into dy by dx is equal to x. Till now, this equation is not a constant coefficient equation, also not Cauchy-Euler equation, but when we multiply this equation by x, multiply whole equation by x, this become x square d2y by dx square, plus this also x into dy by dx, and this become x square. Now this equation is our Cauchy-Euler equation. Here the order of x, the power of x is equal to order of differentiation. The power of x is equal to order of differentiation. Now this is our Cauchy equation. Now we can proceed in the similar manner for finding solution. For finding solution, we can just substitute x is equal to e raised to power t. So the equation on left hand side becomes d minus 1 plus d into y is equal to e raised to power 2t. So this is our symbolic form. We can write it as d square minus d plus d into y is equal to e raised to power 2t. This will cancel out. So the auxiliary equation will be m square is equal to 0, which give m is equal to 0 into 0 and 0. So in this case, we have both real and equal roots, and which is 0. So CF will be given by C1 plus C2t into e raised to power 0t, and t will be equal to log of x. So it becomes C1 plus C2 log x. For finding pi, we have e raised to power 2t as non-homogeneous part and f of d as d square. So for finding pi, we have 1 upon d square e raised to power 2t. As 1 by d stand for one time integration, so 1 upon d square stand for 2 time integration. So we are to doing 2 time of integration of this function e raised to power 2t. Or you can simply put d is equal to 2 also. The both way are convenient. As you like, you can proceed. So we get e raised to power tt upon 4, 2t upon 4. Also substituting back e raised to power t is equal to x, we get x square by 4. So here we get CF plus PI as y is equal to, CF is C1 plus C2 log x and PI as x square by 4. So this is our complete solution yx. But in this question, they have asked about y of 2. And we have given y1 is equal to 0, y dash 1 is equal to 0. So y1 is equal to 0. Substituting y1 is equal to 0. 0 is equal to log 1 is equal to 0 plus 1 by 4 as y1. We get c1 is equal to minus 1 by 4. And the second condition on derivative, so differentiating, c1 differentiation is 0. Here c2 upon x plus x upon 2. X square differentiation is 2x upon 4, x upon 2. Now we have condition on derivative as y dash 1 is equal to 0. Y dash 1 is equal to 0, which will gives 0 is equal to c2 plus 1 upon 2, which gives c2 is equal to minus 1 by 2. So we have the value of c1 and c2. Substituting back, we get 1 by 4 minus 1 by 2 log x plus x square by 4. So this is our solution, particular solution. Now putting x is equal to 2 as they want the value at 2. 1 upon 2 log 2 plus 4 upon 4, that is 1. Here minus 1 by 4. So we get 3 upon 4 minus 1 by 2 log 2. So you can check the solution, which option is correct. 3 upon 4 minus 1 by 2 log 2. So this is our required solution. This question. The main important part of this question is what kind of equation is this? Now moving to our next question. The next question is from IIT JAM 2015. Let yx is equal to ux into sin x plus vx into cos x be the solution of differential equation y double dash plus y is equal to secant x. Then ux is what? Here you can see just within a second that this part is with constant coefficient equation, and from here we get d square plus 1, and the auxiliary equation is m square plus 1 is equal to 0, which gives plus minus iota complex pair roots, and in this case we have c1 cos x plus c2 sin x as cf. So we get an idea here the two independent solution as cos x and sin x, and they have also taken sin x and cos x. So we consider sin x as y1 and cos x as y2, and this will become the method of variation of parameter. Yx is equal to ux into y1 plus vx into y2, and they have only asked about ux. So this is a very simple question. We know the value of ux will be given by the one with y1. So it will be equal to minus integration of y2 into r upon Wronskian dx plus c1. This is as simple as they have only asked about the first part ux only. So here we have r is equal, this is in standard form, as here we have 1. The value of p is 0. Compare it with standard form. The standard form is as y double dash plus py dash plus qy is equal to r. So there is no coefficient of y dash. So p is equal to 0, q is equal to 1, and r is equal to secant x. y2 as cos x. And we are to find Wronskian of y1 and y2. We have y1 is equal to sin x and y2 as cos x. To find Wronskian of y1 and y2, writing y1, y2, their derivative cos x minus sin x. So Wronskian will be given as minus sin square x minus cos square x, which is equal to minus of sin square x plus cos square x, which is 1. So minus 1 is the value of Wronskian. Just substitute these values in ux. Ux is equal to minus integration of y2 into r upon w dx plus c1, which is equal to the value of y2. We have cos x into r as secant x and the Wronskian as minus 1 dx plus c. We know that the secant x will be equal to 1 upon cos x. So this will be cancel out. Minus minus becomes plus. So we get plus dx plus c. The integration of dx is 1 into dx is x plus c. So this is our ux. And we can verify. We have x plus c as a solution. So this is a very simple question, and in a very short time we get to know about the method of variation of parameter will be used here by only saying the part of CF. Now moving towards next question. We have next question from the CSR NET examination 2019. A question: x square y double dash minus 2yx is equal to 0, y1 is equal to 1, y2 is equal to 1. Then find the value of y3 is, the option 1 is 11 by 21, the second option is 1, third option is 17 by 21, and fourth option is 11 by 7. So this is a very simple question. As you can see, the given equation is a Cauchy-Euler equation. The power of x is matched with the derivative order. Here the power of x is 0 and there is no derivative, is equal to 0. So this is a Cauchy-Euler equation. We just replace x is equal to e raised to power t. This will become b minus 1 minus 2 and whole y common is equal to 0. This is our symbolic form. D square minus d minus 2y is equal to 0. So for finding auxiliary equation, replace d by m minus 2 is equal to 0. Here we get two roots. Just simplify it, 2 and minus 1. So this is our real and distinct roots. And in this case, we have the CF as C1 e raised to power 2t plus C2 e raised to power minus t. Substituting back, e raised to power t is equal to x, we get x square, and here we get C2 by x. So this is our CF. And as this is a homogeneous equation, so this will also our complete solution. Now we have given two equations, y1 is equal to 1 and y2 is equal to 1. Substituting this, we get y1 is equal to 1. Here x is equal to 1, x is we get c1 plus c2 is equal to 1. Also, after substituting y2 is equal to 1, we get 4c1 plus c2 upon 2. So solving these two equations, here two equation in two constant, we can solve it easily and we get the value of C1 and C2. Here we have C1 is equal to 1 minus C2. We can substitute here C1 as 1 minus C2 plus C2 upon 2. Now this equation is only in C2. 4 minus 4 C2 plus C2 upon 2. Minus 4 plus 1 by 2 is minus 7 by 2 C2. Or we can write it as 7 by 2 C2 is equal to 4 minus 1, which is equal to 3. So C2 is equal to 6 by 7. As C2 is equal to 6 by 7, so C1 is equal to 1 by 7. Substituting back in the solution is C1 x square plus C2 by x. So we get C1 x square, C1 is 1 by 7 and C2 by x. So this is our yx, and the question asks about x is equal to 3, the value of y at x is equal to 3. So substituting x is equal to 3, it becomes 9 and it becomes 7 into 3, 21. So 9 upon 7 plus 6 upon 21, taking LCM, we get 27 plus 6 is equal to 33 by 21, which can be cancelled on 3, 11 by 7. So this is our required answer, that is 11 by 7. We can see from here the option fourth one is correct, 11 by 7. So the moving towards next question. The next question is from GATE examination 2015. And in this question, we have an initial value problem. X square y double dash minus 6y is equal to 0 and y1 is equal to alpha, y dash 1 is equal to 6. And they have given yx tend to 0 as x tend to 0 positive, then alpha is equal to. Here you are to find alpha. So this is a very different question from all questions. We have given here x double dash plus x square y double dash minus 6y is equal to 0. Again, this is the Cauchy-Euler equation. Here we have the x power 2 and y order derivative is also 2. And here x power 0 and there is no derivative. So this is a Cauchy-Euler equation. Again, we can substitute x is equal to e raised to power t. We get d minus 1 minus 6 into y is equal to 0. So here we get d square minus b minus 6 as a symbolic form. Now to finding auxiliary equation, replace d by m is equal to 0. So in this equation, we are to find a pair whose sum is minus 1 and product is minus 6. That is minus 3 plus 2. Taking m common, m minus 3 plus 2, m minus 3 is equal to 0. So we get m minus 3, m plus 2 is equal to 0. So we get n is equal to 3 and minus 2. Again, real and distinct root. So in this type, we can write our solution CF as C1 e raised to power 3t plus C2 e raised to power minus 2t. Substituting back e raised to power t as x, we get C1 x cube plus C2 x raised to power minus 2. Or we can write C1 x cube plus C2 upon x square. Now we have given two equations here. This is our complete solution as this is a homogeneous equation. So we have here given the two condition y1 is equal to alpha. First condition is this, and second condition is y1 dash is equal to 6 also. So if I would put here y1 is equal to alpha and also y dash 1 is equal to 6, our equation will in alpha remains in alpha. So let's try. If we put y1 is equal to alpha, we get alpha is equal to c1 plus c2, or we can write c1 is equal to alpha minus c2 from here. And also y dash 1 is equal to 6. So first take derivative of this equation y dash x. Y dash x is equal to 3x square into c1, and the derivative of this is minus 2c2 upon x cube. So when we put y dash 1 is equal to 6, 6 is equal to 3c1 minus 2c2. And when we put the value of c1 here, alpha minus c2 minus 2c2. So we get 3 alpha minus 3c2. So finding the value of c2, 6 is equal to 3 alpha minus 5c2, which will give 5c2 is equal to 3 alpha minus 6, and which gives c2 is equal to 3 alpha minus 6 upon 5. So here we get the value of c1 and c2 in term of alpha. So putting back into y, we get, as y is here, c1 x cube plus c2 upon x square, y x is equal to c1 into x cube plus c2 upon x square. The value of c1 as we have c1 is equal to alpha minus c2. So alpha minus c2 is 3 alpha minus 6 upon 5, which is equal to 5 alpha minus 3 alpha plus 6 upon 5. So we get the value of this as 2 alpha. 1 second, here we have alpha minus c2, and c2 is equal to 3 alpha minus 6 upon 5. Yes, 5 alpha minus 3 alpha plus 6 upon 5, which is equal to 2 alpha plus 6 upon 5. So we get the value of c1 as 2 alpha plus 6 upon 5 into x cube plus c2 as 3 alpha minus 6 upon 5 divided by x square. The important part is here, they have given us yx tend to 0 as x tend to 0 positive. So from here we can see when we put x tend to 0, this part will become 0, but this part become infinite. You can see from here, if x square is 0, 1 upon 0 is infinite. So by this part, we will not approaches towards 0. So for approaching towards 0, we have to take this constant as 0. We are to take C2 is equal to 0, because this part making it infinite. And we have the only option of choosing constant as 0. We can choose C2 as 0 as constant. We can choose from any real number, and we will choose here C2 as 0, which will give 3 alpha minus 6 by 5 is equal to 0, and which give 3 alpha minus 6 is equal to 0, which gives alpha is equal to 2. You can see from here Our solution will become, when we put alpha is equal to 2, 10 upon 5, which is 2x cube plus 0. Now, in this case, when we are approaching x tend to 0, our solution also approaching to 0. So for making this condition possible, we are to take C2 is equal to 0. This part must be 0. The constant must be 0. And by substituting 3 alpha minus 6 is equal to 0, we get the value of alpha. And the question also requires the value of alpha. So this is our the solution, the required solution. So these all are the questions from previous years, and there are so many other questions on this topic. You can try them, and if you get any problem, you can discuss with me. And these are the books which you can follow: The Advanced Differential Equation by Dr. M. D. Rai Singhania, The Differential Equation by S. L. Rose, and An Introduction to Ordinary Differential Equation by Covington. These books are very good, and you can also refer other books also.
Now it is the time for asking your questions and making comments. While watching this session by Kajal, uh, what I am thinking is that if one studies seriously this ordinary differential equation, then certainly he or she can score all the marks from this area. Because the questions will be, if you know the right way, if you are able to identify the correct type of the equation, and if you know the method to solve it, then there won't be no other problems. You will get the answer and you will get the mark. But see, for the problems from analysis or algebra, there may be different twisters. The options may be a little bit confusing. But for the problems from ordinary differential equation, that type of issues won't come. So if you know the idea, if you can, the important thing I think is that to identify the equation, identify the type of the equation, and the way in which we have to get the solution, that to be identified, then the things will become easier. So I'm very sure that today's session will be today's session was really helpful for you for scoring a good mark in the coming examinations. Okay, now the time for your comments.
I'm Amrita Warrior. I'm from St. Joseph's College, Devagiri, Kerala. I'm a third year student and I'm about to write my JAM exam also, and also my GATE exam. We have our GATE exam day after tomorrow. And this session was really helpful. As Vinod sir told, there is no twist and turns in the questions for differential. It's only how the method, the correct method that we have to get at that time. And you have discussed almost all the topic: Cauchy-Euler equations, Wronskian, and method of variation of parameters. It was really helpful. And you even discussed about CSIR net problems also, and Gates problem. Thank you so much, ma'am. Thank you for spending such time for us.
Thank you, Amrita.
Thank you, Amrita. Others?
Hello, ma'am. Ma'am, I am Dia from IIT Bhubaneswar, and I am doing my MSc. Ma'am, actually, I want to ask something that in the problem d square plus 1y equal to sec x, here the form of the solution is given in the question, that yx equal to ux sin x, like something, it was given. So we are using variation of parameter here. But when it is not given, we can use that we can only find that particular solution also by 1 by d square, like that. But it will be a bit
Yes, Dia. Actually, this method is used when you already know the part of CF. You know the CF, the two Li solution from the CF part. The second order differential equation is only solved by the method of variation of parameter, and the requirement is you already know the CF, then you can apply this method to find the complete solution, or you can also find the PI part, as we have discussed, the Yx we have the C1 and plus C2 something, and the part which do not have constant, that will be your particular integral part other than that. So this method is used when you already know the CF. And we have in the latest lecture that we can find CF by using 1 plus P plus Q is equal to 0, P plus QX is equal to 0, or another also we have some short tricks for finding CF.
Yes, ma'am. Yes.
Okay.
Thank you, Dia. Others?
Hello, ma'am. I'm Adila. I have just completed my master's from Calicut University, Kerala. So I had this feeling that I have forgotten everything about differential equation. And for this NET exam, I was not actually planning to attend the questions from differential equation. But when I just listened to your class, I remembered this Cauchy equation, Euler-Cauchy equation. I felt the confidence that I can just at least attend the question. So thank you, ma'am. Thank you very much for your class. And also thank you, sir, for arranging such a beautiful session for us.
Okay, thank you, Adila.
Thank you.
Hello. Hello, Kajal ma'am. Thank you for the class. My name is Joshua, and I have a doubt, just a small doubt regarding finding the complementary function in method of variation of parameters. There was one section where you said that the complementary function would take some form when there is 1 plus p x into p or something like that was there. So it was
Okay.
regarding complementary function in that section. Where
See,
did you
we
find
have
that?
so many methods to find even CF. We can use if we have equation of constant coefficient type. So we have the so many. First we make auxiliary equation, then see what type of roots we have. According to that, we write CF. If we have Cauchy-Euler equation, then we will convert into that, and then we can find CF. And also, if we don't know about that it is a constant coefficient, if it other than that equations, then we have some short tricks which we have discussed. Sometimes we have equation by which we cannot find CF. We even don't get idea how to find CF, so don't go for that method of variation of parameter. It's just a method when you already know CF. So the main part is finding CF, and this will only know when you just practice and see the short tricks also how we can find CF. So this is the just I have discussed only I think 2-3 methods only here. We have another methods also. Maybe in next lecture we can discuss that. Okay.
Okay, thank you, ma'am.
Joshua, could you introduce yourself?
Sir, my name is Joshua. I am from Kerala. I finished my BSc from Bharat Mata College, Ernakulam, and I'm currently repeating for JAM 2022.
Okay, Joshua, thank you. Others?
Hello, ma'am. I'm Arya Prasad. I'm doing MSc first year in Calicut University, Kerala. It was very nice class, ma'am. Each and every problem was very explained very clearly, and it was so easy to follow. Thank you for this class, because in MSc program, for the first semester, we do not have this differential equation. So I was recollecting all those things I studied in BSc. Thank you so much for your time, and thank you.
Thank you, Arya.
Yes, others?
My name is Yoji. I am from.
Namaste, sir. Dharmendra, madam.
Yeah. Yes, Joji, you can continue.
Ma'am, I am Joji. I am from Kottayam. I am studying third year basic mathematics. Ma'am, your class was very good. I felt like I was back in class, and I was repeating it was more than what was taught in my class. So very much thank you for that. Waiting for the classes from you, and thank you, sir, for arranging such classes. Yes, thank you.
Thank you, Joji. Others?
हेलो नमस्ते सर धर्मेंद्र सिंह बोल रहा हूँ
Yeah.
नमस्ते मैडम थैंक यू वेरी मच नाइस सेशन I have done many things and I got late today to attend the lecture but I follow सर वेटेज कितना रहता है इसका वैसे IIT JAM में डिफरेंशियल इक्वेशन एंड एडवांस
Differential equation in IIT JAM is about 10 to 12 marks. You can score from that area. In CSR net, you get to score 20 to 30 marks. So it is beneficial. You can attempt this, and it is a very good score. 10 marks in IIT JAM from ordinary differential section. It is a very good score. So you should do that part.
yes thank you madam
Thank you, Dharmendra. Yeah. Any others? If you have anything to discuss, you can answer. Yes. Yeah, Lakshmi.
Good evening, ma'am. My name is Lakshmi. I am a third year PhD student from Kerala. Ma'am, your session proved to me really useful for me because most of the problems and the examples which you discussed during this session gave me a basic and detailed understanding of that concepts like higher order differential equations, especially that Cauchy-Euler and method of variation of parameters, then Wronskian. Then all this gave me a really detailed and deep understanding of these concepts. And thank you so much, ma'am, for explaining that such things. And thank you, Vinod sir, for arranging it.
Otherwise, I think we can wind up here. So once again, very I would like to express my sincere thanks and gratitude to Kajal for being with us. And I'm sure that this last moment brush up of these ideas certainly help our students to get good score in the coming examination. Thank you very much, Kajal.
Thank you so much, sir.
And I wish all participants a great success in the coming examinations.
And thank you very much.